my friends and teachers. My name is Muhammad Uwesh and today I am explaining and presenting a PowerPoint presentation on the topic of file allocation. File allocation, balancing, performance and efficiency. How file systems place data on disk, shapes, speed, scalability and reliability. This deck compares three classic methods, contiguous, linked and indexed, and explains why modern systems blend approaches for real-world workloads. The storage challenge. Files leave a sequence of disk blocks on secondary storage. The OS must map file names to physical blocks while optimizing for fast access, minimal fragmentation, and seamless file growth. Fast access. Minimize seek time for common workloads. Sequential versus random. Low fragmentation. Keep free space contiguous for efficient writes and reads. Easy growth. Allow files to grow without expensive reallocation or compaction. Contiguous allocation. The simple start. Files occupy a single unbroken run of disk blocks metadata needed. Starting block and file length ideal for sequential workloads and straightforward random access using simple arithmetic. Its pros is excellent sequential throughput, on random access, direct block calculation, minimal metadata overhead. Its cons is external fragmentation, hard to resize files in place, requires accurate size estimation at creation. The contiguous collapse. Over time, contiguous allocation produces external fragmentation. Free space become fragmented into small holes. Solutions like compaction are costly and unpredictable. Growth lead to allocation failure or suboptimal copies. Operational impacts. Periodic refragmentation interrupts input outputs. Space reserved but unused files are over-provisioned, not suitable for volatile or large-scale multi-tenant storage. Linked allocation, solving fragmentation. Each file is a linked list of blocks scattered anywhere on disk. Metadata stores only the address of the file's first block. Blocks contain pointers to the next block. Why it helps? No external fragmentation. Files can occupy any free block and grow freely. Metadata footprint. Minimal global metadata. Pointer per block. Stored with data. Linked allocation trade-offs. Linked allocation trades fragmentation for access complexity and space overhead inside blocks. Random access requires walking the chain. A single corrupted pointer can orphan the remainder of a file. Key trade-offs. Slow random reads, sequential traversal. Pointer space reduces usable payload per block. Higher vulnerable to pointer corruption. The fate evolution. File allocation table. Fate moves block pointers into a separate table on disk or in memory. Data blocks are clean of pointers. The fate stores the chain, enabling easier management and improved storage efficiency. The benefits is first removes per block pointer overhead. Second is simpler recovery tool. Scan, repair the fate. Third is widely adopted in early PC files systems. Its limitation is first limitation is fate becomes a single point of failure. Second is large disks require big fates. Performance depends on coaching. Index allocation, the modern standard. All block pointers for a file are stored in a dedicated index block or blocks. The index lets the OS map logical block number to physical blocks directly, enabling efficient random access without per block pointer overhead. Advantages is first advantage is part direct access to any block. Second, avoids external fragmentation while preserving performance. Third, indexing enables flexible multi-level schemes for very large files. Its first consideration is index blocks consume space and must be managed. Second, very large files need multi-level or extent-based indices. Multi-level index. Hierarchical pointers reduce per file overhead. Indirect blocks use intermediate blocks to extend addressing. Single index one level block pointer table for small files. Extend and hybrid. Combine events with indexes for efficiency. Scaling index system commonly uses multi-level indexing and extends. This balance index overhead against ability to address massive files efficiently. Conclusion. Choosing the right allocation. No single scheme fits every workload. Contiguous excels at sequential speed, linked allocation minimize, fragmentation, index allocation delivers random access and scalability. Real systems use hybrids, extends allocation maps, and adaptive strategies to balance performance, space, and reliability. Mesh to workload. Choose allocation based on expected read-write pattern and growth. Use hybrids, extend plus indices. Offers practical compromises for modern file systems. Plan for SLIs. Protect metadata, fed index with redundancy and journaling. So this is the PPT and this is the presentation on the topic of file allocation. Thank you.